So now that we've seen how to run the thread tests for the EX8 example, let's go ahead and take a look at CompletableFuture completion stage methods that trigger after a single CompletableFuture complete. So you could watch the earlier videos to see where this is all coming from. And this is going to show other features of CompletableFutures, in particular, completion stage methods that trigger after a single previous completion stage is done. As with the previous example for the run thread tests, we create a new async tester and we register a whole bunch of, you can see there's about 5 different method references that we register with the async tester. And all of these things, of course, are going to run in the background using CompletableFutures. And after we register all those test methods, we call the run tests method on the async tester. That will start them all up running in the background. And if you call join, it'll wait in the calling thread for all the background threads to finish running. And then it will return after they're all finished. And we do that because we don't want the program to fall off the end of main while there's still background computations running. That will not end well. Those background computations will be shut down and we won't get any sensible results. Okay, so let's go ahead and take a look at these methods. These are in the single trigger tests utility class. And the first one we're going to take a look at is going to be a little test function that tests fraction reduction. And we'll talk about what that is and we'll show how it works. And this is going to use the more powerful CompletableFuture features, but not the most powerful ones. We'll look at those a little bit later. So the first thing we do is we define ourselves a local variable that's called reduce fraction. It's a supplier. And this supplier is going to have some code in it that will take an unreduced fraction. So here is an unreduced fraction. And you can see it's got a big numerator and a big denominator. But we told it, don't reduce yourself. We're going to do that in the background now. We're not going to do it in the foreground. We're going to do it in the background because reduce takes a while on a big fraction. And we then go ahead and take that reduced fraction. Sorry, we then take this unreduced fraction and we say, hey, big fraction, reduce this unreduced fraction. And that computation is going to run in the background, as we'll see. We define another helper here, which is a function that is basically going to take a big fraction and return it in string format. So we're going to take the big fraction, which has been reduced, and we're going to turn it into a mixed string. So again, that'll give it back in like the 4 1/2 format. We're going to have yet another local variable called print result. And as you can see here, it basically takes a string and it appends it to the string buffer, string builder, and then goes ahead and displays that. So let's go ahead and take a look and see how this works. We're going to go ahead and start by calling a very important factor method on CompletableFuture called supply async. Supply async takes a supplier lambda, like this guy, and it stores the lambda expression in an internal data structure and then arranges to have this thing run in some background thread, by default in the common fork join pool. You can designate a thread pool if you want a different one, but we're just going to use the default, which is the common fork join pool. So that will go ahead and start that computation running in some thread in the background in the common fork join pool. When that computation is done, in other words, after the reduction is finished, then this completion stage method is called back automatically. So remember, all these examples are all single previous stage completions. So one thing completed, then we do the next one. So you can think of this as basically a chain of completions. So we then apply this function that converts the big fraction to a mixed string. We saw that up here. And then the last thing we do is we call the then except completion stage method, which will take this particular consumer lambda, or it's really a consumer object, and will then print the results out from the string builder. So when we run this thing, you'll see that these computations are all going to run in the same background thread. And that's why we have all this extra ceremony here about using this stuff, because we want to be able to print the results and say where they're coming from. So that's a very simple example of using a completable future chain. It's basically a fluent interface style model. Let's go take a look at one that's a little bit more interesting. So this one is called test fraction reduced async. You notice this one up here was not async, and so it was able to use a string builder because everything was running in the same thread. Now we're going to do things where some of the computations are going to run in different threads in the background. Overall, the logic is really identical. In fact, I should probably refactor this code to make it cleaner. But this is the same logic we did before, except this time we call supply async like we did before. But now we're going to apply different kinds of completion stage methods. And these completion stage methods arrange to run the computation in potentially a different thread than they completed in the previous stage. So let's say, for sake of argument, that this particular computation runs in thread 2. When then apply async gets called, that could very well run in thread 3. And this one here, except async, could run in thread 4 or whatever. So it's really non-deterministic. It's up to the underlying fork join pool and CompletableFuture framework implementation to decide where to run those computations. And that gives you some benefits. And when you look at the videos that go along with CompletableFutures, you'll get a better sense of why this is something that is provided. The next example is called test fraction multiplication run async. And this is going to use some really interesting methods that are provided in the CompletableFuture API. I believe some of these things came along. Let's see. Well, this particular thing came along early. And so what we're going to do here is we're going to make a new CompletableFuture that's empty. And then we're going to call the run async method. Now, you'll notice up to this point, we've been using supply async. So here we use supply async. Supply async returns a CompletableFuture that will yield a value. In contrast, run async, kind of like the run method on a runnable that's passed to a thread object, it does not return a value. So it can only have output through side effects, which is what we're doing here. So we pass in this future to the lambda expression, the supplier lambda, and after these computations run in the background, we multiply them together, and then we complete the future. So this is very much like we looked at before with the explicit thread model, except now we're using run async instead of spawning a thread. So it's kind of staying within the CompletableFuture family better. So that's the run async version. Now we're going to do a test fraction multiplication with supply async. So this is similar to what we did before with the callable example in the previous discussion of the thread test. And now what we're going to do is we're going to make ourselves a CompletableFuture to a big fraction that will be the result of calling supply async and passing in this supplier lambda. So that supplier lambda is then, once again, going to be scheduled for running in the background, and it'll get run in the background, and then right away we'll get a CompletableFuture to its result, and then down here we can say CompletableFuture join, and that will wait until this computation in the background has finished. So this is sort of the more canonical way of doing things. This is usually how you would write CompletableFutures with supply async as opposed to using run async. And then the last example here, this is something that was added later to CompletableFuture's framework, didn't come out in Java 8. And it's a little bit wacky, but I came up with an example. It's not my favorite example, but it shows the point. So in this case, we're going to make ourselves a new CompletableFuture. And then we're going to attach to it, we're going to register an action to it that when run will append a string to the string builder. So it's like a hook method that gets called. And then we're going to use this very strange method called complete async. And this will go ahead and multiply two large fractions, but it'll first go ahead and run the hook method we registered, this action that we registered, before it will call the supplier lambda pass to complete async. And again, when we're done, we're going to wait for its results. I have honestly never really found a good motivating use case for this. This is somewhat of a contrived example. It works, but it's kind of awkward, and there are probably better ways to do it through the other means we just saw. So those examples are having a single phase that completes. Let's go take a look and see what the results are. So you can see here, these are the results for the single trigger tests. And you can see that we're calling these things, and the first ones are running in the background, but we're getting the results in the foreground. When we looked at the test fraction reduction, we put some extra print statements in there. And you can see that these computations, these are the ones that are being called in the async variants. They're actually running in the background. So we're instrumenting the code in such a way where you can actually see that things are taking place in the background. And in fact, what we're really seeing here is that the results are being printed in the background. And that's because we're using the asynchronous versions of this stuff. So things are actually truly running off the main thread of control, and we're printing the results from a background thread. Okay, so that's the discussion of the single completion stage methods that are part of the Completable Futures framework. And those are pretty straightforward, but of course, there's even more cool ones that we'll take a look at next.